In this video, we explore the core principle of load balancing, a critical component in building scalable, high-performance system. Whether you are managing a small app or a large-scale infrastructure, understanding how traffic is distributed can drastically improve system uptime and performance. So, what exactly is a load balancer? A load balancer is a critical component in modern infrastructure that helps you manage incoming network traffic. It sits between your clients and your backend servers and ensures traffic is spread out efficiently across multiple servers. As seen in the picture, you can see that traffic is coming from multiple places and multiple users, and the load balancers distribute the traffic to the servers which is there in the backend. Why the load balancer is important? Because it helps us achieve maximum throughput. It keeping our system running faster and efficient. Optimal resource utilization, making sure no server is underused or overused. Minimal response time. It improves user experience with faster response. And most importantly, no single server becomes overwhelmed, which prevents crashes and downtime. Whether you are scaling a web app, handling spikes in traffic, or just trying to keep your system stable, a load balancer is the key. Why load balancing matters? First up, high availability. Imagine one of your server crashes. Without load balancing, you are in trouble. But with it, traffic is automatically redirected to healthy servers, so your users never even notice the problem. Next, scalability. As your business grows, so does your traffic. Load balancer let you easily add or remove servers based on demand without disturbing your users' experience. And finally, efficiency. Load balancer help you use your infrastructure wisely. They distribute traffic evenly to prevent bottlenecks and optimize performance. Think of load balancer as the traffic cops of our network. They keep everything running smoothly and prevent a single point of failure. So if you're building any kind of scalable, reliable applications, load balancing is not optional. It's essential. Alright, now that you understand why load balancing matters, let's talk about how it works behind the scenes, specifically the strategies used to distribute traffic. First one is round robin. This one is super common. Round robin sends incoming requests to each server in order, one after the other, like dealing out cards in a game. It ensures all servers get a turn, which helps evenly spread the load. Simple but effective when your servers are all equally capable. Second one is least connections. This strategy is smart. It looks at which server has the fewest active connection right now and sends the next request there. This is perfect for situations where some requests take longer than others. It keeps things balanced when traffic is not uniform. Lastly, there is consistent hashing. A bit more advanced, it uses key data like a user's IP address to generate a hash and sends that user's request to the same server each time. This is ideal for caching and session persistence, ensuring users stick with the same server for a more stable experience. So depends on our needs, whether it's fairness, performance or user consistency, different load balancing strategies can help you get the most out of your infrastructure. Got a favorite load balancing method? Drop it in the comments, please. Okay, now let's take it up a notch. We have already covered basic strategies like round robin and least connection, but what if your servers have different capabilities or varying performance? That's where advanced load balancing algorithm comes in. Imagine you have got a mix of powerful and less powerful servers. You don't want to treat them all equally, right? With weighted distribution, each server is assigned a weight based on its capacity. A higher weight equal to more request. It's perfect for heterogeneous environments where not all servers are created equally. This algorithm makes sure your beefy servers pull more load while smaller ones contribute lesser than the other one. Next, we have response time based load balancing, super smart and dynamic. Instead of static waits or round robin schedules, this method actually monitors real time server performance. It tracks response time and sends requests to the fastest server. As conditions changes, it automatically adjusts where the traffic goes. It is great for environments where performance can fluctuate, like during peak traffic or system updates. So whether you need a balance based on server power or live performance, these advanced algorithms gives you much more control and flexibility. Let me know in the comments which algorithms would best suit your projects. Now that we understand how load balancing works and the algorithms behind it, let's dive into the different type of load balancers you will encounter in the real world. These mainly differ by where and how they operate in your network. Firstly, we have layer 4 load balancers. These work at the transport layer. They distribute traffic based on basic network information like IP addresses and TCP or UDP ports. Because they use low-level info, these balancers are very fast but less flexible when it comes to complex routing. Next, layer 7 load balancer work at the application layer. They look deeper into the traffic, routing requests based on application-specific data such as HTTP headers, cookies, or URL patterns. This makes them much smarter in how they distribute traffic, but that extra intelligence means they use more resources. Finally, we have Global Server Load Balancing or GSLB, which operates on a much larger scale. GSLB distributes traffic across multiple data centers located around the world. This setup offers geographic redundancy, meaning if one data center goes down, another can take over and helps reduce latency by directing users to the closest data center. So it depends on our need, whether it's speed, intelligence, or global coverage, there is a load balancer type designed for us. When implementing load balancer, there are a few important considerations to keep your system running smoothly and efficiently. Let's break them down. First, health checks are essential. Load balancer regularly send test requests to the servers to verify if they are up and running. If a server is not responding correctly, it's temporarily taken out of rotation until it's healthy again. This prevents user requests from going to down or malfunctioning servers. Next, session persistence, also known as sticky sessions. For applications that rely on stateful data like shopping carts or usual logins, it's important to keep a user session tied to the same server during their entire visit. This ensures the user's experience stays consistent and uninterrupted. Finally, SSL termination happens at the load balancer. Instead of each backend server decrypting HTTPS traffic, which can be resource heavy, the load balancer handles these decryptions. This reduces the processing load on the server, speeding up overall performance and simplifying certificate management. Here, the load balancer decrypts the certificate at the load balancer end and sends the traffic further to the servers at the backend. Considering these factors will help us deploy a reliable and efficient load balancing system that keeps user happy. To wrap up, here are the key points to remember about load balancer. Load balancers are essential for high availability system. They make sure our services stay online and responsive by distributing traffic evenly and preventing overload on any single server. Choose the right distribution algorithm for your workload. Different algorithms work better for different situations. Pick the one that best fits our servers and traffic patterns. Layer 7 load balancers provide more control but with extra overload. They can route traffic based on detailed applications info but require more resources to do so. Implement robust health checks and monitoring. Always verify that your servers are healthy to avoid sending requests to servers that are down or slow. Plan for scaling with distributed load balancer. As your system grows, use multi-level load balancing to manage traffic efficiently across multiple servers and data centers. If you found this video helpful, be sure to like, share, and subscribe for more deep dive into tech concepts. Thanks for watching.